Welcome to a brand new episode of Greentech Pulse, where we explore different ways people are, as I've discovered, getting closer to nature. So we've done almost 20 interviews so far, and that means there should be about 20 or so episodes out by the time you're seeing this. And one thing I've noticed is that in this field of sustainability, the best solutions always go back to as close to nature as possible. And today's entrepreneur is working on something. He's working on hydrogen. He's with Irvin from Q Hydrogen. So welcome to Greentech Pulse.
Thank you, Peter.
Thank you so much for coming on. So now, talking about hydrogen, why did you pick hydrogen as your field, as your focus?
So it actually goes back quite a ways, but essentially, I joined the family business. So my father is the developer of the technology. He was previously an industrialist in Latin America and he had large manufacturing facilities that worked with fluid and gas management and built a lot of the back ends for some of the largest manufacturing facilities in the world. And when he decided to leave that world, when you talk about getting back to nature, he had a theory of utilizing what are called hyperbolic waveform geometries. So when you think about an XYZ plane, they're not mathematically calculable on that plane, but you think of like a smooth wave, like a smooth sine wave. Hyperbolic geometries are very common in nature. You think sacred geometry, all of these types of things that run through all of the base of what Mother Nature needs to exist. So the idea was taking that, putting it into or basically taking a block of metal using a CNC mill. So this is a thing that basically has a high-speed rotating drill bit that takes that block of metal, creates the final result. And in this case, it kind of looked like what the first company said, kind of like a waffle mold. So it was a very simple looking design, highly complex in the machine code necessary to create it. But what this first prototype did is essentially you spun it up with two plate surfaces that were slightly separated. That separation created the ability for the air to flow through it, created a high temperature zone and a low temperature zone. At the high zone, about 147 degrees Fahrenheit was the temperature the air came out at, and on the low, it was about 37. And so that was the first interesting note that this technology was not creating an output that was as simple as they originally thought, because the theory was there may be a 10 or 20 degree temperature difference between the high side and the low side. But having such an extreme difference was kind of the aha moment of, okay, this might be something as significant as a subatomic reaction touching the world of quantum and particle physics. And so the hydrogen piece just came out of using that technological thread, using it in different formats. And it was one of those pieces where they were testing it in a sealed chamber one day, a different version of this turbine. It created a buildup of gas without it even spinning. It was just something where there was moisture trapped in this sealed area overnight. They opened the side valve, there was a loud boom. That boom was the formation of some sort of gas. They did some more testing, figured out it was hydrogen, and that was the piece where they're like, okay, at least now we figured out that we can do this. And that was all the way back in 2008, late 2008. So it was just one more piece of the pie until 2014 when the company decided to focus on hydrogen.
Okay, so basically the company designed a turbine and then realized that the waste product or the end product from the turbine was hydrogen and decided to focus on producing the hydrogen. Hope I'm right.
Yeah, I get that's a good way of putting it because essentially when you discover a new technology like this or a way of let's say accessing energy, it puts you into a space of research and development. So you're doing testing in a lot of different ways or configurations
Mm.
of using this idea of these hyperbolic geometries, and that is what created the discovery on the hydrogen side. And then back in 2014, the decision was made, okay, what are we going to focus on commercially, even though we've discovered all these other things along the way? And the decision was made to focus on hydrogen.
Okay. So now looking at your method of producing hydrogen and probably because we've had hydrogen for a while and the traditional method, what's the difference, the main difference?
So the main difference, I'll give you the little bit that I can tell you prior to our opening because we got to keep a little bit of the secret sauce for the big day. But essentially, what we're doing is the first direct processing of water without a heat or chemical reaction that produces hydrogen. And so when you think of the normal methods of producing hydrogen, you're talking about steam reformation of natural gas, which is essentially splitting hydrogen out of natural gas, or you're talking about electrolysis, which is a direct introduction of water to high temperature electrodes that basically separates the water into its constituent components of hydrogen and oxygen. And so this method is a totally different way of doing it. We're talking about, in the case of our New Hampshire facility, you're pulling in water from a river. You are doing some things, of course, to pre-process, but not to the same level as regular hydrogen. And you're literally directly processing with this turbine. There are some other aspects to it as well that make the whole thing work. But the key is this turbine I mentioned, and then the output is hydrogen.
Interesting. So now looking at your turbine, your method and other methods, how much energy do you save, does your method save compared to this other the electrolysis and everything else, steam reformation and co?
So what we are willing to publicly say now, and it is a strong statement, but what we are doing is we will be opening the world's first renewable hydrogen power plant that will be economically viable without a subsidy.
Wow.
So that gives you an idea that even though things exist like the Inflation Reduction Act 45V and everything else, I know that there's some question about what's going to happen under the new administration. We don't need that in order to be viable.
Hmm.
And the key to all of this really is the development of the technology to a commercial stage was never done under the premise of needing a subsidy. It was always, okay, we're doing this because it's something that can stand on its own. And when you look at the world of hydrogen today, methods like steam reformation, that's really the least expensive way in a lot of cases to produce regular hydrogen, but that's gray hydrogen. So basically,
So,
you're using a hydrocarbon to create the hydrogen. So technically, it's not clean. And when you talk about regular green hydrogen methods today, it takes a tremendous amount of energy. You're talking about massive wind farms or solar arrays connected to a electrolysis unit to produce the hydrogen. So it's a tremendous heat reaction that's necessary to create the hydrogen. So what we're doing is completely different from that, and as a result, changes the economics significantly in our favor.
can't wait. Can't wait to see that launch. So now you mentioned your factory being in New Hampshire, by a river by New Hampshire. So why did you pick up New Hampshire and what have you learned siting your factory there?
Sure. So when we decided that we wanted to introduce this technology in the form of a power plant, so basically saying we're going to use hydrogen as the fuel source, we had to do it in an area of the US that was deregulated. So,
Oh,
from an energy perspective, so you, in those cases, you're either the power producer or you own the transmission and distribution infrastructure. So that's where kind of the split is. So I lived in New England for quite a long time. The ISO in New England, so basically the organization that manages the grid up there, is one of the oldest deregulated markets in the country from a power perspective. And so originally we looked at Massachusetts. Someday we'll be there, but there are a lot of difficulties in starting there first. In New Hampshire, I had a friend of mine that worked with me at Raytheon. So I was a program manager for the defense company Raytheon up in the Northeast. And she had become a state legislator up in New Hampshire and said, hey, before you look at or consider Massachusetts seriously, come up to New Hampshire. We're very business friendly. So I ended up meeting with the governor, people on both sides of the aisle, regulators, all of it. And I said, okay, well, clearly this is the place where we need to go. and then went on about a year-long roadshow of looking at a bunch of different pre-existing power plants, so old coal plants, old biomass plants. So woody biomass is basically you're taking wood chips and burning them. So otherwise, it's kind of like a coal power plant. And looking at plants that were basically going out of circulation or business because their emissions were too high, or they were losing their renewable energy credits, so they were no longer financially viable. So the idea was that we would buy one of those, convert it to run on our fuel, and start that way. Now, the place we ended up in was a bit different than I originally thought, but we brought our consultants with us. We chose the place that originally I thought was the least likely target in the state of New Hampshire, being Groveton. So Groveton, New Hampshire is far northern New Hampshire. It's not far from the Canadian border. It's a town whose main employer was a paper mill that was in constant operation from the late 1800s to the early 2000s, and the paper company shut down. So, paper company shut down. Of course, that was devastating to the economy in the area. And when we were looking at everything, a majority of that facility had been demolished, with the exception of one area that had some administrative buildings, a couple warehouses, and then this pre-existing power plant that was the one we looked at. And when I first saw it, it was literally a empty shell with holes in the side, no connection to the grid, and no pre-existing infrastructure with the exception of some stuff underground, so like water offtake, et cetera. And um, it was our consultants that we were working with that basically said, look, this site is probably going to be the best one for you because yes, it's cleared out. You're not going to have a bunch of stuff to rework. And there's some pre-existing power lines, so we could probably figure out a way to use that for users on the site in the future to do private power arrangements. And it being at a paper mill and considering we're a hydrogen company, we're going to be using water. They had me look into how difficult it would be to get a water offtake permit. And so all of that came together. The place that seemed the least likely became the best target. So we purchased the property in 2019. I did get the water offtake permit. The state has been very helpful, and this is when like the lessons learned, those types of things you go through. I'm glad we started in New Hampshire because they have been very open and helpful all the way from a local level to the top levels of the state government, because we are bringing out a new technology. And it's a lot easier when you work with regulators like the folks at the Department of Environmental Services, DES, that we have to work with for our air permit, wetlands permit, all those types of things, when they are open to discussing something that doesn't fit in the box. So I don't think we could have started in a better place. Everything takes longer than you expect, no matter what, when you do one of these things, but we're getting very close now.
Okay, so I think you mentioned a couple of permits, the water uptake permits, the air permits, the wetlands permits, and you also mentioned the easier regulatory environment as a reason for choosing that location. So now for the hydrogen industry, what sorts of, what's the regulatory landscape like?
So generally speaking, there are a lot of basic regulations that exist in the hydrogen world. These are things that have been around forever. A lot of it relates to the type of engineering you have to do in your facilities. So depending on what you're making and how you're making it, if you're using explosion-proof containment for all of your electrical sources, you have to get sign-offs from the local fire brigade. Basically, they all have different names. And a lot of what they do in the hydrogen space from a regulatory standpoint is pretty well known on the federal level, because you do have a lot of facilities throughout the United States that are already producing hydrogen. It's usually large scale stuff with companies like Air Liquide and Linde. A lot of it is at major refining areas. So these are places that essentially your hydrogen infrastructure exists side by side with pre-existing oil and gas refinery operations, that type of stuff. So really the landscape related to regulation and safe and proper use and storage of everything is pretty well known in the space. So that at least that's not something you're having to overcome. Now, one of the things that we have discovered with our technology is something that makes storage and transportation easier. So it also somewhat shifts or let's say lessens the danger associated with hydrogen. And that's one of the pieces that we will be introducing in the next few months when we open our facility. That's one of the fun things beyond the ability to produce hydrogen at an efficient price point with massive scale. We've also discovered some ways to make it safer to store and transport.
Okay. So now we talked about safety. You've made it safer. So now compared to your this thing, what measures have you taken to make it safer? And what are the risks normally in using hydrogen, those safety risks that people look out for?
So the advancements that we've made in that space are part of what we're going to be releasing soon. So that's part of the opening secret sauce at the moment. But in the stereotypical landscape, normally you're dealing with hydrogen in gaseous form or liquid form. In the gaseous form, it's normally stored at pressures between 10 to 12,000 psi, so highly pressurized tanks. So these tanks are also built in a very specific way where they are insulated in a certain way. They have very thick walls, et cetera. They're extremely expensive containment setups basically for hydrogen gas, especially when you're talking about large amounts of it. And then from a liquid perspective, if you're storing it in that phase, it's normally between 4 to 6,000 psi, and you have to store it at cryogenic temperatures, so extreme cold. So when you think about both of those setups, one is high pressure, one is extreme cold, you have an extreme amount of infrastructure cost related to storage and transport with either of those methods. So even if you've solved, let's say, the issue around producing green hydrogen efficiently, let's say at the main point where you have it, if you're stereotypically, if your point of use is not within a very close proximity of your facility, it almost doubles the cost when you're talking about storage and transport with either of those methods.
Okay. So now, looking at your hydrogen, which industries have you seen that are most interested in adopting and using and of taking the hydrogen from your facility?
So right now we're starting off as a power plant.
Mm.
We'll be providing electricity, at least initially, to right now it looks like a mobile data center. And then we will be expanding that use to others on the site as this industrial envelope or footprint, whatever you want to call it, grows. Where our facility is located, there's roughly 140 acres of land around the site. And the idea is the area is an opportunity zone. There are a lot of industrial users that would like to be located in that zone because they have human capital, so workers that can come in and work at these facilities. They're doing contracts with Canada in a lot of cases, so the proximity to the border is great. But the only thing that has kept them from doing it is the price of electricity in New England is extremely high. And so when we started this, the price of power was 14 to 17 cents a kilowatt hour. Now it can get as high as 30 cents depending on how you're using it and where you're located. And so our plan is to provide power at rates more similar to what you would see in the southern and western US in order to incentivize industrial users to come to the site and create an economic engine to bring this whole area back to life. So one of the things that we see is taking that model and replicating it over and over again in other places throughout the US and the world where something like that makes sense. So the power aspect is a really strong market for us. And then the other that we are going after very specifically at the moment is marine decarbonization. So we've figured out interesting ways of being able to utilize our fuel in the marine space, and we'll talk more about that publicly soon. But so we're talking cruise lines, cargo ships. So there's a big pull in that direction. And so we're working with various labs and organizations to have various certifications put in place to allow this to happen. And then also in Europe, there's a strong pull in countries like Sweden for these power plants that I talked about. So creating facilities that essentially run on our method of producing hydrogen and then using that to produce electricity that would then go into the Nord Pool, which is basically their power grid setup. And then we're having discussions with groups in Germany for uses like green steel. There are also discussions about use in cement production, as well as ammonia itself, because a lot of people don't realize, but hydrogen is a main component in ammonia, and the production of ammonia is one of the largest users of hydrogen globally. And so those are all really big targets for us. So when we talk about the general discussion related to hydrogen, most people focus on automobiles. So consumer transportation, potentially hydrogen fuel cell trucking. Those are pieces that are on our roadmap, and there are some folks that work with us that are more focused on that piece, just on the side, because the idea is we're looking at the possibility of joint ventures or cooperative agreements with large companies that have engineering groups that can take this and really turn it into something in that world. But we're focused mainly internally on large industrial users.
So large industrial users, and I think this has a lot of use cases from what you've talked about, reducing the cost of electricity in your area. You have the marine and decarbonization, automobiles, fuel cells, things like that. And also you mentioned ammonia production. So there is a lot of applications. I can see this finding a lot of use everywhere. So now for
Yeah.
when would you be launching? When can we hear more about what you have to offer? Is there a fixed date yet,
So
or
we are going to be launching this year. Exactly when this year, there are a lot of things going into it. I'm hoping by the middle of the year.
oh,
We are working through a few things related to permitting, use, some testing that we need to have done prior to the opening, but it will be sometime this year.
amazing, amazing. So now for anyone listening to this episode, this should be out by May. So mid this year too. So for anyone listening to this episode, they want to learn more about your technology, they want to learn more about what you're doing, they want to maybe work with you or anything else, what's the best way they can reach out to you and continue this conversation?
Well, the best way to reach us is our website. It's www.qhydrogen, the letter Q, just the word hydrogen.com. And then we have a link that goes to our box that is monitored by a group of people. And so they will direct questions to the right areas of our organization. And we're happy to work with folks and talk to folks that have interest.
Amazing. So for anyone who wants to continue this conversation, we just had about maybe 30 minutes or thereabouts. If you want to go deeper on this conversation, you want to learn more about what Q Hydrogen is doing, just go on to qhydrogen.com, ask your question, and it will be sent to the right person for you to continue this conversation. So thank you so much, Whit, for coming on Greentech Pulse today.
Thank you, Peter. Happy to do it and look forward to keeping in touch.
Thank you so much. And for anyone listening, I know you're listening because you're interested in hydrogen. Did you learn something new? Did you find out about something you didn't find out about before? Did you find this interesting? If you know anyone else that would find this topic, this episode interesting, share it to them or wait for the next one next week. Till then, bye for now.